And today I'm going to talk about how do we need to communicate our work effectively in various situations. And I'm assistant professor at the Department of Physics at the University of South Bohemia, and I have more than 12 years of experience in science, and I would like to share with you what I learned along my journey. So now I cannot, sorry, I cannot turn my slides. Try again.
We can see your.
Yeah, it was just the first song. So great science doesn't speak for itself, and you have to deliver it. Science communication and storytelling is very important at this moment, as we as scientists don't only communicate anymore in the walls of our labs, but also we should know how to communicate science when we write grant proposals, when we present in front of evaluation panels, during the scientific conferences, and more often nowadays when we try to reach public. So the way we communicate science can shape how people perceive the value of our research and whether they choose to support us, and more importantly, if they are going to fund our research and projects. In a world where the misinformation spreads rapidly, fueled by the social media, artificial intelligence, and more often lack of scientific literacy, it is our responsibility to be clear and accurate and engaging messengers of the science. This just doesn't mean that we need to learn how to explain our research, but also it means that we need to be able to talk about scientific processes, finding the evidence in the way that makes sense to everyone, from the policymakers to the high school students. So the ability to tell a compelling story about your work is no longer a luxury, it's the necessity. So learning to communicate clearly and creatively is a skill that strengthens not only our career path, but also our connection between the science and society. So there are different ways to tell a successful story, and here I will present you 3 steps. So first of all, you have to make it simple. Science is a complex, and your job is not to make it even more complicated. You can use analogies when you try to talk with general public. So instead of explaining the protein folding, you can make an example that it's like folding the origami. When you talk about the work of enzymes, you can use analogies like lock and keys. When you talk about physical processes like energy transfer, you can make an example as a running relay. So the second part is like when you speak to people, you have to connect through the common challenges. If you need to present the data that are part of the results of trial and errors projects, and it's led you to some unexpected discovery, you can start your presentation with a question. You can ask, have you ever worked for months only to find out that your hypotheses are wrong? Or if you talk to like more wide audience, and you try to explain the importance of invisible forces and interactions. So you can approach by asking, have you ever thought about how much of the world around us controlled by the things we cannot see? And then you can build up on this story. So last but not least, people, they more often believe in the speaker before they start to believe in your data. So you have to start with the confidence. Speak with the authority, slow your pace, and emphasize the key points. So think about your research not just as a data and methods, but a story. And the story can be built on 4 key elements. It's the future, the journey, the challenge, and the insight. So the future, this is your vision. What could the world look like if your research succeeds? What problem could be solved if some technology is created? What new understanding can begin? So this is the point where people should understand your why you're doing this. So the next part is the challenge. This is the tension. So what obstacles or questions are you trying to overcome? Is it scientific mystery or it's just a technical barrier? So this gives your story the purpose. Your journey, this is your process. How you're tackling the challenges. What experiments did you try? What setbacks did you have? And what breakthroughs did you make? This is the main part of your story. And last but not least, this insight, this is your discovery. This is what you learned during the process, and you should explain what it means, its significance. This is the moment of impact that your audience should take with them and remember. So here's the example of my research project. We will start with the vision at the first slide to get the engagement and excite the audience. So imagine the world where we can control the chemical reaction as easily as tuning on and off button. Think of the medicine that can be activated under your skin at the precise place and time. Think of the material that can be changed with the light, or artificial photosynthesis mimicking nature's most efficient energy system. This isn't the science fiction, this is what we're working towards right now. By using lasers, we try to control the photoreactions at the molecular level. Why this is hard? Light-driven reactions happen on ultra-fast time scale, from femtoseconds to picoseconds, starting from photoisomerization of proton transfer. So molecules don't react as we expect because there are many competing pathways where the energy gets lost. And light is very hard to control. In a way, it's similar to piano. If you press the right key at the right time, you get music. If you do a mistake and hit the wrong ones, you just hear the noise. So how do we solve it? We use tunable ultrafast laser pulses to selectively excite molecules, and we guide them along desired reaction pathway. We use multiple spectroscopy setup, where one of the pulses initiates the reaction, the second one drives it to desired photoproduct, and the third one monitors it with the precise delay. By analyzing the transient absorption spectra, we track the molecules and its changes like in a slow motion display. By using machine learning models, we can predict the outcomes of the experiments and refine the experimental parameters. So applying this methodology in proteins, we want not only to understand how these processes work, but also to actively control the photoreaction. And in future, this will help us to design the synthetic light-driven systems for many different applications. So you should leave your graphs and data for the articles and the supporting information. And when you are presenting, it's not about showing how many experiments or work have you done. It's about guiding your audience through the story your data tells. So a crowd of slides with the messy graphs will lead to the overwhelming the people. Instead, you should highlight the key features, use the simple annotations, and lead the eye of the audience, and they will see what you are saying. So don't just show your data, but make it meaningful. So, how to communicate science effectively? First of all, think about your audience. If you present in a very big conference or in the congress, there are a few people who knows your topic, but the rest of the audience is very broad. You should simplify your presentation to focus on one main message as a big picture and impact. So you should avoid using the jargon, use analogies instead, and try to hook your audience from the first slide. If you're visiting satellite meeting or professional workshop, the audience at these places will be most probably from your field, but they might not know about your research project. In this case, you should keep your presentation on a technical depth, but clear in structure, and you have to share your challenges and encourage the discussion during the Q&A session to get like brainstorming if you should overcome something, and yeah. So the tools that you can use already in your presentation, it's to keep it to keep the 10-20-30 rule. So for the 20 minutes presentation, you should keep 10 slides. Use a 30-point font, which will be visible. You should focus on one big idea, on the main message. You can record yourself before the presentation just to see your body language and basically to practice and maybe to get feedback.
Valentyna, I'm sorry, the volume sound is not very good. Can you speak louder or increase the microphone?
I'm not.
It's yeah.
Okay. Now it's back, or can you
Okay.
hear?
Okay. Yeah. Yes, we can hear, but something with sound. But it's okay. It's okay. Probably we will fix in our.
Okay.
Okay. Okay. Thank you. I'm sorry.
Yeah. So if you're going for the on-site conference, I would suggest to get your own laser pointer, because sometimes during the conferences these are multi-function and you'll always be prepared. So if you need to present your research to the wide audience, general public, or the school students, you should use the storytelling instead of methodology and data. So you should use the visuals and make it interactive. And for example, here we had a researchers' night last year where we had to demonstrate what our research group is doing, and we study photosynthesis. So instead of going to the complex light-driven photosynthetic processes, we just show why the light is important for photosynthesis. And another way you will need also to present your research, it's posters at the conferences. And any poster should have a clear sections, simple key message. You can practice your verbal presentation, have a one-sentence summary, have multiple versions of the presentation for the more wide audience, or for the people who are specifically for your field with the more details, and you should engage with the listeners. Here I have one advice that you can try to find out what works best for you. So last year I went to a couple of the conferences, and on one of them I have moved my title of the poster to the side on the layout. And this was the conference when I got the biggest engagement during the poster session because people would just stop and ask me the questions. So just because the posters stand out from the others. So um, um, last but not least, whatever you present at the conferences, either it's a first year preliminary result of the project or it's a nature paper, it's important to network with the people and build long-term connections. So my simple advice is to go through the book of abstract, find the posters and talks that you're interested in collaborations or as a workplace or as a project itself, and go and meet these people and make the contact with them, follow up, connect on LinkedIn, send an email, and try to maintain this connection. During my PhD, postdoc, and later career, I made collaboration with the people who I met at the conferences, and then we would make the collaboration like starting the next week or in 7 years, it doesn't matter. So make contact, follow up, and maintain this connection. So I would like to thank organizers for inviting me today, and I would like to thank you for listening, and let's stay connected. And if you have any questions, I will be happy to answer right now, or you can send me an email and we can catch up later.
Thank you very much, Valentina, for your nice presentation and for the suggestion that I'm sure will be useful to everybody in the audience. I have, before opening the floor to the questions, I have some curiosity. Do you have an opinion on how the artificial intelligence can help us in improving our way of presenting our results, or you think it will not be of help?
Like you can use the artificial intelligence to make the visuals, like for example, yeah, everyone I think nowadays are doing like some pictures. I think you should it should be your thoughts, but you can use artificial intelligence to help you to brainstorm something. I often use it like I start as a conversation, you know, like and asking questions, and then we go, and then I know what's like the final thought. I mean, I get it myself, but you still use it as a partner to communicate. But it also has to be like trained for your own work. So I think that as more you talk to it, as better it will work by like your voice or what you want to find out. The downfall of the using artificial intelligence that it will be full of not very unique thoughts. I mean, like because the model learns, and if it will learn on the data that was produced by artificial intelligence, we will get to the loop where it will stop to create new answers. You will just get to the same answers all the time. Yeah. So that's kind of.
Thank you. And I have also another curiosity. In maybe the second slide, you wrote about some yes, on the treatment of social media, and could you please elaborate on that? Why social media are a treatment?
I think it's because like if you're a scientist, most of the time you don't have time to go on social media and share the real results and evidence. People who share the most are not scientists. Usually, I mean, there are some great networks and accounts that make like popular science and like physics accounts and YouTube channels with the lectures and so on. But what gets popular is usually some misinformation. We've seen it in 2020, how fast it was spread. We see it when we start to see, I mean, like as a mother, I see the accounts of like anti-vaccines and stuff, and these are getting super popular. And as a scientist, as I say, it's our responsibility not only to speak of your own research, but because most of us have a PhD, critical thinking, opinion, that we should also share this with others. Like, and if it threatens others, we have to say it. So you cannot not engage in the conflict just because you don't want it to have a conflict. If it will threaten someone's life, I don't know, like example, this anti-vaccines, or like when they say the cancer research is not like you would go, I don't know, drink some special holy water and you will be treated from cancer. Or, you know, as a scientist, you know that the science works in some cases and people can be actually cured. You should not stay silent at this moment. So.
I like very much your call for responsibility. I like it very much. Thank you very much, Valentina. So now I let the people in the audience first in presence in Kiev and then in the Zoom. You can also write the question in the chat if you want. Please, you can go ahead with your question or comment.
Okay, we have a question.
Thank you for your presentation. I want to ask just one question. You said that it is very good to develop some connection with your listeners. And are there any tips, any special tips, how to develop a connection with your audience when this is some online conference, Zoom, for example, with many cameras turned off?
Yeah, I think that as a presenter, I felt like I can share my LinkedIn because like it's something that people can search my name fast, they can connect and write me. Or like you can contact the organizers then to ask for the email if the other person doesn't mind that you will connect with them. Yeah, I think online it's very hard, but you know the names of the people who presented. If you're interested in their research, just write them a mail.
Probably, I think Dmitro wanted to understand another feature. This is when a lecturer is talking with. Actually, it is very often happen when you give a lecture to the students, and you have such situation when you are speaking with computer with turn off cameras, and there is just black squares, and the interaction with audience is difficult. I think this is the point. And also, of course, your answer about how to contact to the scientist who is interested for you. Of course, this is interesting. It's fine.
Yeah, I think that if I would need to present, I mean, like not to present, but teach online, as I know in Ukraine, most of the universities do nowadays, then I think that I would make my own rules, like that the cameras should be on, and like
So
as a lecturer,
your advice is to give own rules.
yes, or
Okay.
you can do or you can do the interactive sessions, you know, like when you have 50 minutes lecture, for example, so 30 minutes you can talk, and then 20 minutes it can be engaging in the conversation and like some discussions. Most of the, even adults and students are also adults, but if you're talking about master and bachelor students who are like 20s, so it's not like adults yet. And most of the adults, they can focus like 10-15 minutes and then they will get lost too. So that's why if you have 1 hour of lecture, it's probably better to break it with the small like interactions, asking questions, that people will not like fall asleep or turn off the camera and leave. I don't know.
Okay, thank you very much.
Yes, you touched there's so many interesting points during your presentation. I think that also this point that you're discussing now, to make connection also in presence, I think many young people underestimate the importance of this. They are very shy maybe, and I like very much your advice to go and speak with other people at the poster session. I would allow also to ask a question during the presentation because it's another way to engage and to have after maybe some conversation with the speakers that are close to your field, to have the connection. I think this is an important point that in early stage people underestimate. I like it very much. I wonder if there is thank you. I wonder if there is some question from the audience in Zoom. Some comment. I see now there is.
Yeah. Mm-hmm.
Yeah. How does audience psychology influence the effectiveness of humor and questions in a presentation?
So I think it's important to know who you're speaking in front of. So you have to understand your audience first, because of course, if it's a wide audience, people will be very happy if you put some humor and stuff. About the questions should not always be something that everyone should answer. For example, if I ask you a question, I don't expect you to answer, but I expect you to think about. You know, like you can answer inside your head, like, how this thing works, like what is the challenge or something. It just it's not interactive question, but and if you use the humor in a very specific audience, you're from narrow field and you know that everyone will understand the joke, use it. Why not?
There is another question from conference hall. Can we ask?
Sure.
Okay, Olga.
Thank you for your presentation. It was really interesting. My question is about the open science, open data, because you mentioned the access to the scientific literature as the limiting factor to like spreading the science. And nowadays there are a lot of like great scientific books, great scientific articles that aren't free. You need to pay for subscription if you want to read specific magazine, or you need to pay for the specific article and for some, I don't know, scientific book. If you want to have an access. to this. And my question is about what do you think about the open data and open sciences? Because on the one side, this is better for students that don't have money but want to do their own researches. But on the other hand, it's like the extra way for scientists to get some money and for scientific magazines and people that write these scientific books to get some extra money. And what's the best option you think for the solving of this question?
Okay, thank you. I understand it from many sides because I was studying in Ukraine as well, so I was in the same situation of the access. Now I think that we in Czech Republic we are privileged that we have options of subscription for the National Library of the Academy of Science that give access to most of the journal publishers. So in the way I don't have problems to accessing articles, the new ones that come out every month. With the books, yes, I don't have also access, and I think it's a big problem. If it's a book that it's really to your research relevant, maybe you should ask some funding for this. Yeah, I'm sorry, with the books I cannot help. The books are from different publishers, it's different people. If you need some specific chapter, you could try to approach the author of this chapter. Like if it's a scientific book that has like an articles, like every chapter is different person wrote, write this person, maybe he will answer you and he will send you the chapter.
Thank you.
Thank you very much. Also, I would like to mention, beside the strategies that you are suggesting that are very useful, I think following your call for responsibility of the scientist, I think that it's a good strategy to, before submitting the paper, to submit the pre-submission form of the manuscript or book chapter to archives that are open. Because many people, many articles have an open version, that is the version before it was submitted to the editor, before the reviewer did their work. And I think that if we take these habits, when we cannot publish open access, this will be for help for everybody. So it will not help you for the book. Valentyna, what she said is, I think, I don't know other option. But it's good also to consider now to submit the manuscript before in the archive, like X archive or bioarchives, and they will have a number, and once the paper is published, automatically there will be a link in the archive to the published paper, so you won't lose a citation if they are given to the archive paper.
I think it's a good point. Also, one thing that I can mention, what I was doing during my PhD, I was asking people at different university to download the paper for me. Different university and institution, they have different accesses. Sometimes it's based on which direction university is more to in research. So they will choose this open access publishers. And so, yeah, networking, make friends, ask someone to help you for something specific. I think if you ask someone like 3 times a year, it's fine to send the article. I mean, like, so
Yes.
there's one. one more question about the introduction for the 20-minute presentation. How long it should be? Well, I think that the introduction, it depends. I think that in the first minute, you should already say your motivation. And if you count as introduction, then just like 1 minute. If you wanted to introduce the complex topic, of course, it can be 3-4 slides. So means like 6 minutes, 5 minutes, maybe. But I think in the first 1-2 minutes, everyone should understand what you're going to talk about.